We have a linear equation with two fractions in it. It's not going to be hard. First, I want to go back and I want to review some characteristics of fractions that you may be a little bit foggy on. So let's just say, don't think about this for just a second. Let's just say I want to multiply 3 times 2/3. How do you do that? Well, here's a whole number. So when you multiply a whole number times a fraction, you're going to put the whole number over 1, because when you multiply fractions, you multiply straight across the top and straight across the bottom. Now the thing is, now that you have the same number in the numerator and the denominator, even though they're in different fractions, they're multiplied together, so they divide out to 1. They reduce down. So what do you have left? 2 over 1, which is 2. Let's look at what happens when you do 5/7 times 7. Same thing. You're going to do 5 over 7 times 7 over 1. The 7's cancel out. 5 over 1 is 5. So you can conclude from just these two examples, anytime you multiply a fraction times its denominator, these cancel out and you're left with just the numerator. Now let's look at what happens if I multiply a fraction by a multiple of the denominator. What's a multiple? Well, it's a number you get when you multiply that number times something else. So let's say 6 times 2/3. 6 is a multiple of 3 because I can get 6 when I multiply 3 by a number. All right, you're going to wind up with 6 over 1 times 2, 3. You can still reduce this down. 3 and 6, both of them can be divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Now you would multiply across the top and get 4. So let's look at what happens if I took 5/7 and I multiplied that by a multiple of 7. What's a multiple of 7? 14. So how many times does 7 go into 14? 2. And 5 times 2 is 10. So when you multiply a fraction by either its denominator or a multiple of that denominator, what you get is a whole number. You get rid of the fraction. That's the technique we're going to use to simplify this equation a little bit before we ever start solving it. Now, there are many different ways to solve this equation. Those 4 steps to solving an equation, those are not rules. Those are best practices. Those just help you solve your equation in the most efficient way, usually. But anytime I see a fraction where I have, or an equation where I've got fractions in it, the first thing I do is get rid of the fractions. And it's not as hard as you think. Look at the denominators of all the fractions in this equation. I have a 2 and I have a 4. What is a number that 2 and 4 multiply to give you? That's going to be 4, right? Could you use 8? Well, yeah, but that's overkill. So go with the smallest number. What's the smallest number that both of these go into? 4. So what we're going to do is we're going to multiply. Now remember, when you solve an equation, that equation is given to you balanced. This equal sign means that these two sides are balanced. Your only rule is to keep it balanced, and you do that by always doing the same thing to both sides, or doing it all the way through the equation. So let's multiply 4 by this whole equation. Now let me stop right here and explain this. 1/2 times x, how would you do that? If you do 1/2 times x, you put x over 1 because it's actually a whole number, and then you would multiply all the way across the top. So what you actually have is x over 2. So let's rewrite it like that. Let's just make this x over 2 instead of 1/2 x minus 6 equals, let's do the same thing up here. 3/4 times x is the same thing as 3/4 times x over 1 which gives us 3x over 4 minus 9. Just rewriting it that way sometimes helps people understand this step a little bit better. Now, I'm going to have to multiply every term in this equation by this 4. So that's 4 little multiplications I'm fixing to do. Now when I multiply 4 times x over 2, remember this is the same thing as 4 over 1 times x over 2. Your 2 goes into 4 how many times? 2. Then you're multiplying across the top, 2x, across the bottom, 1 times 1 is 1. So you've got 2x, okay? I'm not going to do every single one of them out that much, but I just wanted you to see where I'm fixing to get all this, okay? So that's going to give me 2x minus, all right, 4 times 6 is 24. Now when I come here, 4 times 3x over 4. This number and your denominator divide out to 1. So what you have left is just the 3x. You don't have to multiply this one times anything because the denominator and your number here match. Here, I had something left over. That's why I had to multiply the numerator. Here, there's nothing left over. And then 4 times 9 gives me 36. Now, do you see how much better this looks? All right, now we're into our steps. And our steps, the first step is to simplify. There's nothing to simplify. The next step is to get your variable terms on the same side of the equal sign by manipulation. I have a 2x and a 3x. I need to get rid of one of them. I'll choose, since they're both positive, I'm going to choose to get rid of the smaller one because I'm going to have to subtract and I don't want to get a negative number. Will you get the right answer if you choose to get rid of 3x? Yes. You'll just have a negative to deal with. So let's subtract 2x from each side of the equation. Those cancel out. So I have negative 24. 3x minus 2x is x. And then I have minus 36. Okay? Now, that's step 1, step 2. Step 3 is to get rid of the number that is added to or subtracted from your variable term. Well, 36 has been subtracted from the x. How do you get rid of something that's subtracted? You add it to both sides. Now over here, this makes 0, so I have x. Negative 24 plus 36. Opposite signs, subtract and take the sign of the larger number. 36 minus 24 is 12. The larger number is positive. So your answer here is 12. If you want to check it, take 12, fill it back in to both of those x's, and do the math. Okay? Hope that helped you. Bye.